I'm not mad. I'm just disappointed. Today I'm going to talk about the most common misconception I've ever seen in basic mathematics. I've seen people repeat this that should know better. I've even seen it in some instructional materials at, not quite a textbook, but like instructional materials at a tutoring center I worked at a few years back. And the misconception I'm talking about is the big controversy apparently of what the hell this means. The square root of x. What the hell is that? Well, I'll tell you what it is. First of all, of course, let's say x is a positive real number so that this is defined and, what is this? It is by definition the positive number whose square is x. By definition. If you don't believe me that that's what the symbol means, well, first of all, you can just go on Wikipedia or whatever and do that, or you can just listen to what I have to say and maybe that'll convince you. So when I write this, what am I saying? I'm referring to the positive real number whose square is 9. Some people say that when you write this, you have to refer to both roots. You have to include both roots. They say, no, you have to include both. No, I don't. What are you going to fight me? No, I don't. By definition, it is the positive root whose square is 9. So if you write this, congratulations, you are wrong. This is one number. This is not two numbers. This is false. So this is true. This is false. What if I wrote this? Yeah, that's true, because this, we've established is 3. So plus or minus this is also plus or minus this. So this is fine. What if you wrote this? Ah, negative this? This is this, so that's negative that. Ah, very simple stuff. The square root of 9 is 3 and only 3. It is not two numbers. I don't have to refer to both roots. I can do whatever I want. Now, what you can do to x is you can go ahead and look at this function and plot it in whatever you want. You know what it's going to look like? It's going to look something like this. Oh, look at that. It's always positive. Well, I'll be damned. Yes, because this is going to return only positive numbers, because when you use this symbol, you are saying, by definition of that symbol, the positive number whose root is x. The positive number whose square is x. Now, let's talk about that there equation solving. What if I want to solve this equation? Well, how do we solve any equation? We look at the operation that's being done and we do the inverse of that operation. What is the inverse of squaring? It's not square rooting. It's plus or minus square rooting. So when you solve this equation, if you want to undo this square, you do the inverse, which is plus or minus square root. If you only take the square root, you're only saying 3, and you also did not cancel out the square. Recall that in order for a function to have an inverse, it has to be 1 to 1. X squared is not 1 to 1. So we would say that x squared does not have an inverse. But this is not quite accurate. The better thing to say is that x squared does not have an inverse function. It does have an inverse relation. The requirements for having an inverse are really the requirements for having an inverse function. All relations have inverses, which are also relations. You just switch the two coordinates, essentially. So the inverse of x squared is not a function, it is a relation. And that relation is plus or minus the square root of x. We can see pretty quickly that the inverse can't be the square root of x because the square root of x is a function, and x squared, by not being 1 to 1, cannot possibly have an inverse function. In summary, if you have a positive real number and you put that there square root symbol on top of it, you're referring to its positive second root by definition. That is the number you are referring to with that notation. If you don't like it, well, man, I'm really sorry to hear that, but it is better. It is the better notation. Well, let's adopt the other notation for a second. Let's say that the square root symbol automatically includes both roots. So we're going to take the square root symbol to include both roots just implicitly. Okay, let's say I have this number 2,378. and I want to talk about its positive second root. Well, under the previous notation, that would be this. But now we're taking this to include both roots. So how do we specify the positive one? Well, I mean, this is already two numbers, right? This is the negative square root and the positive square root both at once. So what do we do? Do we do this? Is that how we denote the positive second root of 2,378? That's a little strange, isn't it? Or do we do this? That's a little more reasonable, but still weird. How about we just cut out the middleman? Let's go ahead and say, this is the positive root. This is the negative root. And this is both roots. Doesn't that seem totally sane to you? Why would you want this symbol to include two numbers? No, let's just take this to be the positive one, this to be the negative one, this to be both. That's what a normal person would do. All right, but seriously, I think I've said all I have to say about this little issue. I see this misconception a lot, so I felt the need to make sort of a public service announcement about it. Look, the point is that this notation means the positive second root of 7 by definition. That's what the symbol means. When you see this, there is no reason at all to think about the negative second root of 7. It's not being mentioned here. That's the point. But anyways, I hope you enjoy this this little unscripted rant that probably makes me look a little crazy. But I'll see you guys later.